So we're going to start off with a budget set problem, and this is going to kind of cover the first 2 or 3 lectures from Econ 401. So we're assuming that we would know, something about utility functions, preferences, budget constraints, budget set. We're hoping that we know these terms while tackling this particular problem. So I would consider this problem a bit on the trickier side, mostly because there are lots of different steps to take in order to get to a budget set. But I will try to tackle each and every one of these steps as carefully as I can. So the problem asks to create Anne's budget set, and there's a particular utility function, and what bundle does she optimally consume. So Anne has an income of $50, and so she spends her income on popcorn and beverage. So it's kind of an easier, we're kind of looking at it in a two goods kind of a world. Popcorn costs $10 and a beverage costs $5. However, the store where Anne buys beverages has a special deal. After you've bought 6 beverages, then you can buy each of the beverage for $2.50. So that's the problem. So to start off this problem, one thing that I want to mention is what I like to do is put the one good that is changing, that's getting that deal, that is having that discount on the x-axis, and put the one that is not changing on the y-axis. You will realize this later on when I show you the actual graph, why I did that. So I know that my beverage, right, after we've brought 6 beverages, that's when you're kind of getting that discount. So I'm going to put my beverage on the x-axis and my popcorn on the y-axis. So now part A, we see, okay, when we're trying to draw a budget set, we want to have our budget constraint, our simultaneous equations, or 2 different equations. And this is a more difficult problem because we're seeing that deal, because we're seeing this discount. So our 5x plus 10y comes from, here's our 5. Our 5 is the price, and our x is that particular good, or the amount of good that we're going to be using. So that is that particular expenditure on beverages, and 10y is our particular expenditure on good y, on our popcorn. So together we have that equation where it's 5x plus 10y is less than or equal to 50, because you will not be spending more than the income that you already have, right? Our income is $50. Same way we do the same thing for line 2. So now, the first thing that I like to do is to figure out our kink point. And our kink point is that point at which the slope does not really exist, because that is a point where you're changing the slope, kind of, okay? You're going to have one equation, right? One equation with a different slope, and another equation with a different one. That's why maybe you figured this out in your previous calc courses or something, that kink points do not have a derivative because the slope is undefined at that point. So here you're going to plug in your x, because we already know that our x is 6, right? That's a 6 that at that 6 beverages, we're changing our graph, our line. So when you plug in 6 for the first equation, we get 5x plus 10y, right? So that's 30 plus 10y is equal to 50. And then we solve that equation and we get y is equal to 2. So our kink point is going to be 6, 2. Now you might be asking, wait, why are you using the first equation? Why not the second equation? Here I'm going to say that so when you're reading the question, it says after you have bought 6 beverages, meaning that you have already bought the 6 beverages, and any number above that is when you're going to be using the equation number 2. So at 6, we are still at equation 1. We're still paying that $5. That is why here you will see we're at x is less than or equal to 6. All right, so here's our kink point. Now we're going to be looking for the y-intercept. To find the y-intercept is actually pretty easy. We just, normally when we do the y-intercept, we're going to plug in 0 for x and then find y that way. So here we know that we know that 0 is less than 6, right? So we cannot be using this equation. We cannot use that. 0 is less than x. We can only use this equation, and that's why we are using this one. And so 5 times 0 is 0, and then 10y is equal to 50, and then y is equal to 5, and that's where I get my y-intercept from, okay? And so you're going to see that this will really help us create our final graph. So that's why we're separating it into different pieces. Finally, this is step 3, and I would say that step 3 is probably the most difficult step, but it's completely doable. Here we're going to figure out our x-intercept. So when we're looking at like y-intercept or x-intercept, so for y-intercept, our y-intercept was that popcorn, right? We're assuming that, okay, if we are buying 0x, as in like if we're having 0 beverages, how many popcorn, what's the highest amount of popcorn can you buy? And that was our 5. With the same intuition, if we have 0 y's, okay, we're not buying any popcorn, we're only going to buy beverages. Now here's where the tricky part comes, because we have this deal, right? After the 6 beverages that you buy, we have our little deal. So let's see what it's like when we buy our first 6 beverages. We're going to have $5 times our 6, that's going to be 30, and that's the $30 that you spend on your 6 beverages. But wait, I still have my $50 in my pocket, right? But you're subtracting that 30, so now I have $20 in my pocket. Now my 7th beverage is going to go to the second equation, right? It's going to go to the second equation because x7 is greater than 6. And now we're going to have, okay, so now we're going to use our second equation, and that's going to be 2.5x, right? Because that's my $2.5 given from my question here. 2.5x plus 10y is equal to 20. Again, we're getting rid of y because we don't want to buy any of the popcorn, so we're left with x is equal to 14. And that is going to be our x-intercept. Now that we have all our main points, right? We have our x-intercept, we have our y-intercept, and we have our king point, we can finally come to our graph. And if you have worked through this problem, you should probably get a graph, something that looks like this, okay? Our budget line kind of represents the slope that we have, and that should be pretty easy to kind of see. And so you see how the budget line, our slope kind of changes at this king point. And this is our 6.2 is our king point. And here's our beverages on the x-axis and popcorn on the y-axis. And here's my step 3, right, where I said that, okay, I have $30 that I already spent on my first 6 cookies and $20 to spend on my last 8 cookies, right, because 6 plus 8 gives us 14. And you can see that, oh, that deal really works well. I'm spending only $20 to get 8 cookies, whereas I spent $6. Whereas I spent $30 to get only 6 cookies. So that works out, and here's what our budget set would look like. So another thing that I want to add is that you want to make sure that your x and y axis both end up at that $50 mark, right? So here we spent $30 for the first 6 and $20 for the last 8. And then for the y-axis, we spent just 50, right? We want to make sure that both of our x and y-axis at the end up at that $50 mark, because that is when you have maximized you've spent all the money that you have left, and that is what you would optimally like produce with the money that you have. We're going to start our part B, and B was, suppose that Anne has these following preferences over beverage and popcorn, and this is a utility function. So what bundle does Anne optimally consume, right? For this problem, you do not have to use like comparing the marginal rate of substitution to the price ratio because of the fact that it's a perfect substitution. You don't really have to do that here. So what I did here was I picked the two endpoints. We know that our optimal condition will be in one of the two endpoints. And here are the endpoints, right? We have 0, 5 and 14, 0. That's a good way to see that, oh, will Anne completely produce popcorn or completely produce beverages? That's why I chose the two endpoints. So I chose the two endpoints, and then I basically just plugged in, okay, our B is 0 here, obviously, because that is our x value. And P is y, so that's why I did 3 times 5. Plugged it in, I got 15, and then the same thing I did, and I got 14, right? Here, so for utility functions, it's more of an ordinal concept rather than a cardinal concept. So ordinal means that we care much more about the ranking of these numbers rather than the actual numbers. And cardinal, if it was a cardinal concept, we would care more about the numbers. Oh, wow, the 15 matters so much. Here, the 15 and the 14 don't really matter. But what really matters is the fact that, oh, 15 is higher than 14. So we see that, okay, Anne really does prefer that 15, that 0 and 5 more than the 14 comma 0. And okay, where does the 0 and 5 come from? Oh, that it comes from the y-axis, and that's a popcorn. So we can assume that Anne would optimally prefer the corner bundle, which is the popcorn only. So she would optimally want to buy popcorn only. So yeah, that would solve our problem here. So that was the end of our problem, and if you thought that this was helpful, please feel free to like and subscribe. Thank you.